Welcome to this session. This session we discuss a problem on how to integrate x squared over square root of 9 minus x squared. So the first thing that we have to observe from this problem, so solution, since the integrand has a term of the form square root of s squared minus x squared, then we make a trigonometric substitution of the form x equals to a sine of theta. So which tells us that this part 9 minus x squared is equal to terms of the form x squared minus x squared. So this is not hard to see that a is 3, because 3 squared is 9. So it tells us that in this question we are making the substitution x equals to 3 sine theta. And then this is the same thing as saying sine theta is the same as x divided by 3. Now, let's see. Square root of 9 minus x squared is the same as square root 9 minus x squared. Squaring 3 sine theta is 9 sine squared theta, which is the same as 9 into 1 minus sine squared theta. And we know 1 minus sine squared is cos squared. So this is the same as the square root of 9 cos squared theta, which is the same as 3 cos theta. And when we say x squared is nothing but 9 sine squared theta. Since x equals to 3 sine theta, then dx is 3 cos theta d theta. Now let's write the integral. We have the integral of x squared over the square root of 9 minus x squared dx. So where is x squared, you put 9 sine squared theta. Where the square root of 9 minus x squared, from our calculation, we have gotten 3 cos theta. Where we have dx, we replace by 3 cosine of theta d theta. Now you see this will give us some terms will cancel out. This term and this term cancels out, so that we have the integral can factor out 9 and then say sine squared theta d theta. And from our earlier discussion, to integrate sine squared theta, we use the identity 1 minus cos 2 theta over 2, then the theta. Now we can factor out 2 so that we have this integral as 9 over 2, factor half, so 9 over 2, 1 minus cosine of 2 theta, and then the theta. And so we'll have 9 over 2 into, this will give us theta. This one here, using integration by substitution method, will give us minus sine of 2 theta divided by 2. And then we add a constant c of integration. So let's see. We know that sine 2 theta is given by twice sine theta cosine of theta. So a half sine 2 theta should be the same as a half times 2 sine theta cosine of theta, which will be just sine of theta cosine of theta. So this integral, which is x squared over square root of 9 minus x squared dx, will be 2 over 9 into theta minus sine theta cosine of theta, and then you add c. But you don't leave your answer here because theta was not in the question. Since sine theta, or 3 sine theta is the same as x, which is the same thing as saying sine theta is the same as x over 3, then draw a right angle triangle. And then from that right angle triangle, try to get the value of other trigonometric functions in terms of x. So sine is opposite over hypotenuse. So this will be 9 minus x squared because of Pythagoras theorem. So cosine of theta will be given by, cos is adjacent of hypotenuse. So we'll have square root of 9 minus x squared over hypotenuse, which is 3. And theta, because sine theta is given by x over 3, then theta is sine inverse of x over 3. So picking this value, and picking this value, and replacing them into this solution, we have, so hence the integral x squared over square root of 9 minus x squared dx is 2 over 9, and then theta is sine inverse of x over 3 minus, so remember we had 9 over 2, and then so we have 9 over 2 times the value of cos sine of theta is x over 3 cosine of theta is square root of 9 minus x squared divided by 3. And then we add the constant of integration c. So you should see that this 3, 1, 3, 3, 3, 1, 3, 1. So this will be 2 over 9 sine inverse of x over 3 minus x over 2 square root 9 minus x squared, and then plus c. So that is the solution for that given problem. So the next session we give more examples on how to find trigonometric integrals involving substitutions. Thank you.